I'm heading the biorobotics lab in at the University of Florence, which is located. Part of the lab is located inside an hospital, so the hospital rehabilitation hospital of Fondazione Dognocchi, and this is a big value for us to have a laboratory inside the hospital to work every day with the clinical staff and with patients, and we have also strong collaboration with other universities in Tuscany. Our group, as you can see, is composed of several people, among which a postdoc, a researcher, PhD, and so on. And by the way, we are just hiring. So if someone is interested in the future, join our lab.
And we don't make any assumptions about the reason there's the analysis could be an electricity outage or the actual.
Okay. So if someone is interested to join our lab for future position, then we are just hiring. So what do we do, and how to start this this lecture? Let's start with this concept, so which is about our research portfolio. So for active anti-aging, we are used to develop technologies that could be useful for assisting people and operators during the daily life activities, but also to try to assess and to measure things that can be useful to provide services to the users. So what we are going to show in this lecture is a number of technologies that have been developed that belongs not only to the field of robotics, but also to the field of sensors that could be integrated with robots and that can be used to provide assistance, but also to measure things like clinical assessments. And this could be interesting because when combining all this data with machine learning techniques, it's possible to develop some decision support systems that are very useful for clinicians in healthcare applications. So this is what we are going to see today. And the idea is to consider this large set of sensors, robots, and software entities that are pervasively distributed in the environment. So we can do a scenario like this one in an hospital in which we have robots for assisting in logistics, in transportation, but also in interacting or for providing services to the users, or for clinical decisional support application, let's say. And and this is also true for sensors that could be placed in the environment. And the concept is that this ecosystem that we can call a sort of ecological cooperative system for stakeholders, for users, could be translated without any change in a very standardized and interoperable way. These are the two keywords, interoperability and standardization, can be easily translated basically in other environment. We can change the environment, but the technology are the same. And this is, let's say, one of our objectives as a research team, basically. So let's start now from some definition first, and let's see what are the ingredients of these technologies that can be used in active anti-aging. The first ingredients that I like to put on the table is robotics, and particularly starting from service robots. What a service robot is explained here. So a service robot is a robot that can operate in a semi or fully autonomous way for providing services to humans. What I like to put in evidence is that we are talking about autonomous or partially autonomous robots. So we don't need necessarily to have completely or full automated robots in this case. We need robots that can cooperate, and we will see the definition of cooperating in next slides, with humans. And this is important because this is one of the most important aspects that can differentiate service robots from the more standard industrial robots that we are used to think. Service robots are typically explained in some categories, like, for example, public service robots, like in military, space available, aviation, rescue, but also in entertainment, like companion, game, exhibition, also for tourism, or other application like healthcare, cleaning, security, and so on. So as you can see, we have a lot of possible application of service robots, which is a bit different from the factory robots, so the industrial robots that instead are more specific for some more repetitive application. And let's have a look to the difference between industrial robots and service robots. I think this is an important concept we have to take in consideration, because it's the base of the development and the design of service robots. What you can see here is, for example, a typical industrial scenario. And one of the things that you can observe is that there is a big complexity of the environment, let's say, with a robot doing specific tasks. But the things we can observe is that the humans are not at all present. So where are humans? Humans are not present. This is the main issue, the main characteristics of industrial robots. What you can see is that the robots are in some way also taken in some restricted space where humans cannot enter. And there are security systems if humans try to enter in the workspace of robots. This is for security, of course, issues. The difference is, and a comparison between services and industrial robots is here. So we have industrial robots that can do specific tasks, so are not flexible at all, not customizable at all, but they are very precise and accurate and repetitive for some specific tasks. On the contrast, service robots are highly flexible, adaptable, but with a low precision and accuracy. On the other side, we have that industrial robots are used in environments very structured, as we saw in the previous slide, and are used to replace human tasks. Above all, those tasks that are very strong with a big load for humans. On the other side, we have service robots that can work in largely unstructured environment, like home environment. Think about home environment with dogs and cats, for example, and can cooperate, can work with humans, are not supposed to replace humans. This is an important part. And finally, the difference between industrial and service robots can be considered from the design point of view. While in industrial robots, we are mostly working in a technical product design, in service robot, we have to think about the so-called user-centered design. So to take in consideration those aspects that involve the humans in the design process, and that can be also measured and evaluated, let's say, in terms of acceptability, but also, if you like, in terms of dependability. When we develop robots, basically we have to integrate these main aspects. So we have to give the robot some capabilities. Robot capabilities are at the basis of developing a robotic application. So we have developed software, the control at a different level, software at different level, from very close to the hardware until close to the higher level of the services. And we have to provide them some specific capabilities, as I said. So some of the capabilities are localization and mapping, navigation and planning, cooperation and manipulation or grasping capabilities, integration with the other sensors, so interaction with other sensors, but interaction with humans. And also have some particular characteristic or capabilities, if you like, intrinsic capabilities in the system to be dependable and acceptable. So these are very important aspects that we have to consider in the design of such kind of robots for this application. And this, of course, it's a very important part that it's fundamental in the design of robots, and is the necessity to consider some aspects related to the robots, which are the dependability, the acceptability, also the sustainability, because robots at the end should be able to be deployed in the environment, so they should be in some way accepted also by a legal and ethical point of view, other than even also from economic or social point of view. Now we are concentrating. We are now in this lecture. We are not talking about the sustainability. I just introduced to you that it exists, but let's focus much more on the dependability. But let's have a look at the acceptability. When we think about acceptability in the design of robots, we have to consider the possibility that the robots could be could have a good usability, could be customized, could be useful, safety, aesthetically acceptable, and so on. So these are the most important parts of the acceptability. For what concerns the dependability, here we are considering those robots or those machines that in some way are robust, that can do what is the objective for what they have been programmed. And to do that, they should work in a perfect way, should not make errors, because we have robots that are close to the humans, and if robots do errors, it could be a problem for the humans. So we have to be very, very, very careful when we develop, design, and put or deploy robots in a stronger and in a close connection with humans. So that's why I insist to make this point very important. So the dependability. So the dependability is a term which is in some way related to the robustness, to the reliability, to the capability of the machine to do the job in a very well way and without creating errors and damages to the humans or to the environment. How to measure the dependability? For measuring the dependability, we have basically some attributes. The attributes are the way to measure the dependability, but we have also some other aspects related to dependability, which are the impairments and also the means. Means are all of those aspects that are considered during the design and the development of the robot. So are those preventive actions that are performed to make a robot as much dependable as possible. For example, using redundance on sensors or using some specific sensors or bumper for prevent some contacts or damages. So it's a part about it's something which is in the way of the design and the development. Instead, impairments are the reasons, let's say, the causes that can be considered in the error, let's say, in a not well functioning or working of the robot. While the attributes are those, as said, that can be used to measure the level of dependability. Let's make an example. Fault, error, and failure are connected between them. What could happen, for example, is that if we have a mobile robots, for example, that uses laser for navigating to avoid obstacle and to identify path to navigate in the environment, what is possible is that the laser can, for example, can be broken at one point. If the laser sensor is broken, means that the robot can have error in localization. So the state vector of the localization of the robot can be wrong, can have numbers not coherent with the environment. So what could happen? Could happen that a robot could not reach some specific target. For example, one target could be the charging station, if the robot is supposed to go to the charging station alone. And at the end, we can have error and failure in recharging the robot. So this, as you can see, when a sensor is broken, could generate errors in the state of the robots, but also failure in what are the functions of the robot, and so on. So in the investigation of faults, errors, and failures is important to understand when or where there are some specific failures or not situation of not working, and how to measure these. How to measure these? As I said, we can use the attributes. Okay, I will. When we consider a specific schedule of how to design and to maintain a dependable robot, what we can do is first analysis of the impairment, so the possible errors that or failures that the robots can have, the implementation of some issues, really some countermeasures to avoid failures, for example, having redundancy of sensors. Then the dependability can be validated, so the robot as it is developed and designed could be validated, so the performance can be assessed, and then the robot is ready to be used with users. Okay, the attributes that we are discussing today are safety, availability, reliability, maintainability, adaptability, and security. These are very important attributes that we have to consider in robots and that we can use to validate the dependability of the robots. The definition is here for each attribute is here. So the safety is, of course, the intrinsic characteristic of the robot to not create damage to humans and environment. The availability is the readiness of the robot to provide in a correct way a specific service. The reliability is the continuity to give a correct service, and also in the period of time that is supposed to work. For example, we can have a robot that could be fully available, so good availability to take a battle and give the battle to the user, but could not be reliable because the robot can take 5 minutes to take a battle, so it's not useful. If the robot can do well something in a very long time, it's not useful. So we have to consider the two options, the two attributes of availability and reliability. Then we have the maintainability, which is the possibility of a robot that could be easily repaired or maintained in case of damages. The adaptability, which is about the capability to adapt to the environment, to the change of the environment. And then the security, which is much more about the data that the robot can generate and that can be used in a specific way, preventing, guaranteeing confidentiality and integrity of data. Are you, it's okay, my connection? So sometimes I see that my video is not working well. Can you hear me?
Yes, Filippo, we can hear you, but we have some connection problem. Okay, now it seems okay. Try.
Okay, let's go on. So after this definition of service robots and the particularity to be dependable and acceptable, let's go much more in detail of service robots. A category of service robots is those that could be called social robots. So those robots that can work, as I said before, in an autonomous or semi-autonomous way, but that are particularly oriented to interact with humans. So here there is a specific physical and cognitive interaction with humans, which means that these robots are supposed to interact using typical means and rules of the human's behavior. So social robots are those robots that in some way should be much more similar to humans in the shape, if you like, but also in particular in what they can perceive and express to the human, using the social rules and the behavioral rules. We will see something in detail about this, but let's go on. We will focus so in social robots now, from now on, because social robots are specifically useful in active and healthy aging, in assistance, in decision support systems, situations, in medical or healthcare application, in companion robot applications. So we will focus much more in those social robots from now on. But let me introduce to you another concept that I already introduced before, and is the necessity to have robots integrated in ambient intelligence, in smart environments. And this enable me to introduce a concept that sometimes is also named as Internet of Robotic Things. So we are used to know about Internet of Things as a combination, as a collection, as a large scale collection and presence of sensors that can measure anything, anywhere they are placed, interconnected between them, that can share data, can share intelligence, and so on. But let's think that also a robot could be used by IoT system, or vice versa. IoT system can use robots, for example. So in some way, we can say that thanks to connectivity, robots could be integrated in an IoT network, in an IoT system, and we can in some way have the concept of the Internet of Robotic Things. I think that the Internet of Robotic Things is surely the future, because today we are seeing a convergence of technologies. In particular, we don't have any more single technologies like robots, AI, IoT, or sensors or sensor network alone working in a standalone way. Today, we have robots that need a lot of additional capabilities, important capabilities. We are working more and more on robots that are not only based on classical control model to work, but also they are based in learning mode to act. So robots that can learn, can improve their capability to be controlled under the direction of a specific task. But to do this is basically giving to the robot those capabilities that I have listed in a few slides ago. So robots need some specific capabilities: navigate, talk, understand, express emotion, recognize emotion, manipulate objects. All of these capabilities are today more and more based on artificial intelligence algorithms or machine learning. So let's say that robots today, to have those capabilities, needs necessarily AI. So there is a strong connection between AI and robots. But let's think to the concept that AI could not be dissociated with a large collection of data. Large collection of data means that why large collection of data? To have well-trained algorithms, we need data. We need a large data set. And this can be done only if you have several sensors everywhere that can measure everything necessary for the application and that can move. So that's why AI, to have data, requires IoT. But at the same time, IoT requires sometimes to the movement, the action that can be given only by the robot. So in the end, we can say that in order to guarantee capabilities to robot, data to the AI, and action to the IoT, we have to consider this a strong triangle, magic triangle between robots, AI, and IoT. And this is, let's say, the concept that we can call Internet of Robotic Things. Okay, we will have this for our application. So don't be afraid to see all sensors if we are talking of biorobotics. When we talk about biorobotics, we talk about robots, but also sensors connected to them, and above all, also algorithms. And some scenario could be, for example, a logistics scenario in a city to provide services to the users. As you can see, we can have robots in the city, for example, for delivery services, and also sensors distributed in the city. But we can have the same at home. We can have sensors, robots, intelligence distributed everywhere. Okay, so these are typical scenarios. Now, these are the technologies that I tried to introduce to you. Now, let's consider how to decline these technologies for active and healthy aging. Okay, so we have IoT, AI, and robots, which are in some way a sort of unique big technology. How to go in this direction? And when we talk about robots, we talk in particular to social robots. Okay, so let's just consider the first assumption. The first assumption is that when we develop application of human-robot interaction using social robots, it's interesting to see that those features that we are acquiring with the sensors for giving the robot the capability to perceive specific aspects of the interaction, in some way are the same features that can be used to perceive specific pathologies or disease. Basically, when we develop a robot that is able to interact, recognizing speech, recognizing facial mimic, so recognizing emotion, when we develop all of these perception modules for human-robot interaction, we are acquiring some features that can be easily translated in the medical world. And this is a very interesting point, because we can develop nice interacting robots that can be at the same time used to give clinical information to the user, or to the clinicians, or to the doctor in some way. This can be very interesting, because if we suppose, and this is the second assumption, if we suppose that this data could be collected and could be used more for a clinical point of view, we are able to introduce some paradigm of prevention and diagnosis for specific chronic disease. So, based on these two assumptions, now let's have a look. Let's have a look to what it could be possible to do with a robot. Let's explain these two concepts, these two assumptions, looking more in the block diagram of a robot. So this is a typical, this is a typical, let's say, control loop in which we have a robot, as you can see here, which is interacting with human for any kind of interaction, which could be cognitive or physical. The robot has sensors. The sensors are acquired and are used by a specific internal system, a control system of the robots that can then decide on the basis of this sensors input how to react with the humans. So, for example, based on the sensors, the robot can talk, can navigate in some way, can implement some strategies for moving close to the humans and so on. So this is a control loop in which the robot perceives the human and interact appropriately with the human. These sensors provide to the robot a number of features that are then used and processed to do that. But the same sensors, and we are going in the second loop, which is on top, are those features that can be used to give clinical information to the user, to the users, but also to the caregivers or to the clinicians. And so what we have at the end? At the end, we have a double loop system that can have two applications, interacting with humans and provide information about the disease. Let's go more in detail.
Filippo, sorry, Filippo, we have a little bit lag now. Just wait 1 second. Okay, start again, because sometimes there is delay, a little bit lag. Okay.
Okay.
Thanks.
Now let's go much more in detail about this concept. In this table, you can see you can see a list of possible features that can be perceived by the robot for implementing specific human-robot interaction application. For example, in perception and interaction, the robot could acquire, for example, the motion of the users that are interacting with the robot. So the robot, when interacts with the humans, should measure how the user is moving, is walking, is sitting, is moving hands. So the robot should have, for example, camera or other sensors that are in the environment, or also wearable sensors to collect the data about the movement of the user. The robots in human-robot interaction could, for example, acquire the facial mimic using, for example, camera, again, RGB 3D camera, for example, or thermal camera for acquiring information related to, for example, autonomous nervous system or emotional stuff, physiological parameters, voice tone, for example, the gaze or the eye movement to interact better, to understand the engagement of the users, or to guarantee engagement, to engage users in the interaction, as humans do. When a person wants to interact with another person, should do a sort of engagement, to take their attention. Okay, I'm talking with you, so. And the same should be the robot, and the robot can do that looking at the eyes of the robot, of the humans. Okay, but there are a lot of other aspects that will be considered. For example, speech analysis, recognition, the behavior of the humans. So these are all the aspects that the robot should acquire to interact well with a human. But if we translate these features that are part of this interaction perception, we can see that the same features can be used, for example, in frailty, to measure frailty. Frailty is like, for example, sarcopenia. For example, if we have a robot that for interacting with a human should measure the posture, the gait, how the human is walking, how the human is going, what kind of gesture with hands is doing. Well, we can say that to measure sarcopenia, it's interesting that we have to measure the same things. So for sarcopenia, we have to measure the gait, we have to measure the walking performance, and for example, we have to measure how they use the hand in some lowered task. And as you can see, it's the same. And also in neurodegenerative disease, or like Parkinson or mild cognitive impairments, looking at the facial mimic or speech tone or other motor symptoms are the same that we can use for interacting with humans, to make robots interact with humans, but also to measure things that are related to this kind of pathology. And measuring the behaviors of the users for interacting interactive could be used also to measure state of depression, of apathy, and so on. So what I want to say is that if we develop nice robot interacting with humans, we are very close to extrapolate data that could be used for clinical application, for healthcare application. And if we translate this property in assisting people at home or in any space or in any environment, we can surely create a sort of ecological system that can continuously assist and give information related to the health status of the user. So this is the point of the biorobotic concepts of active and healthy aging. And the system at all is then this. In a more technical detail, if you can see, we have a robot with the cameras, sensors on the force sensors, like strain gauges. We have lasers here, all data that can create the perception layer of the robot, perception model of the humans to the robot, that can be used to plan the behavior of the robot for interacting, but at the same time can develop some decision-making modules that can give support to caregivers for providing a well-optimized, a better optimized and effective assistance or clinical support. When we have what the robot can do with this interaction capabilities, the robots can develop some, for example, social navigation capabilities, can work with context of humans working, as you can see, and so on. I will give you more details soon about that. Now let's okay. Now let's before going on now, after giving you this concept, let's see what is more in detail human-robot interaction. Human-robot interaction could be physical and cognitive. So let's have a look at both of them. What's physical human-robot interaction? When we talk about, before going into detail, let's say two things that are, when we talk about human-robot interaction, we have to consider some points. The first, we have to pursue a specific coexistence between human and robots. So robots and humans live in the same environment. We should design and develop in order to preserve a long-term safety during the human-robot interaction. And we have to, in some way, try to implement some strategies in which humans and robots can cooperate or collaborate. Now we will see the difference between collaborative and cooperative robots. Okay, so this is what we like to do. And this is particularly true when we have also physical human-robot interaction. In order to develop something like that, we have to be able to give the robots some behavioral capabilities. Behavioral capabilities that can bring the robot on the possibility to understand human intention, to sense, understand, learn, and adapt to what is necessary to be done in the interaction and for the user assistance. Here you can see some example. For example, in this picture, you can see some example of manipulators or wheelchair or other robots that in some way can give a physical support to the user. And it's important here that we have, as I said before, dependable, safe situations and robots, and also capability to adapt to the situation. We don't have repetitive tasks here. Let's have a look at an example of a robot we have developed, for example, in our lab. This is a robot for walking assistance. Okay, this is a robot for walking assistance. I don't know if you see this in the right way, but here don't care about the video now. The point is, I have another video about that much better. The point is that we have this robot able to adapt to the walking capabilities of the user, because the robot can have a lot of sensors like laser in rangefinder in front, but also in the rear, force sensors, video camera in front and in rear. We can use also sensors on the user, like wearable sensors. And we can measure everything about that. We can measure the gait movement, the gait of users, the movement of users, the posture of users. It's important for the robot, for physically interacting with users, to know the posture of the user, and also how the gait is performed. So the robot, to adapt to the user when performing walking rehabilitation tasks in walking, has to measure a lot of things related to the gait, the posture, and so on, which are the same parameters that are used to understand the level of rehabilitation, or the let's say the movement indicators, performance indicator. Let's see this video, which is much more better, I think. This is a result. So this is a project we have developed, and we have used it to support elderly people in some specific rehabilitation task. You can see here. We have also force sensors on the handle here, and the robot can feel how to move in order to be compliant with the capability of the user to walk. So as you can see, we have sensors first on the users to measure the gait analysis, but also to measure the posture, okay? And this is a robot that was tested in one of the hospitals in the south of Italy, in San Giovanni Rotondo, IRCS San Giovanni Rotondo, Casa Sollievo della Sofferenza. So then there are some specific interfaces to adapt the robot to collect data about the users and so on, okay? So here we have an important physical human-robot interaction, and the robot should adapt to the working capability of the user. So if we just 1 second, because okay. Just to condensate some requirements of human-robot interaction, but I think I have already explained to you. It's we have to consider some biomechanical human analysis. We have in these cases, we have to predict the human motion. We have to consider also some capability of the robot to take a decision on how to act and to move. We have a lot of things related to the control, planning, and learning to have some reactive behavior and so on. So these are a lot of elements that are necessary to be used in developing such kind of robots when they have to physically interact with the human. In the case I showed you before, the robot can also talk, can also receive some information from the user. So there could be also a cognitive interaction, not only physical, even if I'm taking consideration of the physical interaction. This is another example, just to give you some information about the safe physical human-robot interaction. I like to show you a video in which a manipulator can in some way act to avoid possible damage to the humans. Here there is from the University of Rome, there is a work in which they developed a specific control system for giving the robot the capabilities to avoid humans when the humans is coexisting in the same environment, in the same workspace of the robot. So, what is? So, for example, you can see here a manipulator that could is trying to avoid any damage, any impact with object or with the humans in this case. But the same could be done in a more specific application, like this robot which is supposed to hold patients at a hospital. And this robot has a lot of sensors, force sensors, but also, as you can see, in this case, it's performed with a mighty. I will go much more faster. So this robot is supposed to it's a bit slow now, my laptop, my computer. Okay, this robot was supposed to hold people when they are in the bed that should be carried out in another place. And this is a big problem in hospitals, because nursing staff is not so strong to do that. And here you can see how to design and develop an arm that could, let's say, guarantee the equilibrium of the object that is holding on the arm itself. So here you can see this kind of exercise in which the manipulator is controlled to avoid that this object can fall. In this case, we have just a position tracking control. And you can see that there are some errors. But if there are some force sensors to control the position of the object, you can see that the robot can avoid to make the object falling. And this is, let's say, an aspect of achieving a redundance of sensors and have a more dependable system. Okay. Okay. So now let's take in consideration some definitions which are about the kind of physical interaction. Usually the physical interaction is mapped on two properties, which are agency and proximity. The agency is the available autonomy of the robot to perform a task or a part of the task. So agency is related to the certain level of autonomy of the robot. The proximity instead is the level of interaction in terms of space, in how close, how far the human and the robots are working. And if we see here a diagram proximity agency, we can see, for example, that we have wearable robots like exoskeleton, which could be particularly, which works in a very strong close contact with humans, which are working in the proximity at personal level, so in a very short distance. And here, in the other coordinate, we have the agency. So we can see teleoperated robots, which are with less agency. Instead, we have other robots which could have much more high, full autonomy in some specific task. This approach can enable us to identify at least three kinds of interesting way of interaction, which are supportive, collaborative, and cooperative. And this could be in some way also the time now to understand well when we say collaborative robots, cooperative robots, what's the difference, or supportive robots. Let's say that the supportive robots, collaborative robots, and cooperative robots are a different level of how the robot and the humans are engaged between them. So when we talk about supportive robots, we talk about supporting robots when given a specific task to be reached, to be achieved, the humans can do it also alone, but if there is a robot, the robot can give support to the humans. But the presence of the robot or not is not necessary to the humans to achieve the final scope. So in this case, the robot is just supportive, but the finalization of the final task could be done by the humans anyway, let's say. Just let me show you an example in which we have humans which is doing a task, the robot is doing another task. The combination of the two tasks brings to achieving the final objective. But if the robot is not present, the humans anyway can reach the final task. And this is the case in which we have a robot and a human which are playing a song. For example, the robot actually, what's the point here? The human can play the song with the piano. I can go home. That's no problem. But the presence of the robot is important because it can give the rhythmic bass using the other instrument. So as you can see, the robot is supporting, but not necessarily to achieve the task. In the collaborative way, instead, the situation is different. To achieve the final objective, the human is doing its own task. The robot is doing its own task, but both are necessary. If one is not present, the task cannot, the objective could not be achieved. And this is the typical collaborative robotics. When we talk about collaborative robotics, we are basically talking about that. Humans and robots has different tasks, which are both important, but as you can see, are two dissociated tasks. So the robot is holding some elements, for example, facilitating the human in developing, in doing a specific task. But as you can see, they are doing two different tasks, completely different. Both of them are necessary to achieve the final objective, okay? But look, when the robot is acting, the task of the robots and the task of the humans are not properly influenced in a dynamic way. They are just necessary both, okay? Why I say the dynamic way? Because there is another situation in which both tasks are necessary, but are intimately connected between them in a dynamic way. It is when there is an exchange of forces between robots and humans. When there is an exchange of forces between humans and robots, we are talking about the cooperative robotics. So cooperative robotics is when we have a robot doing a specific task, a human doing a specific task. The combination of the two necessary tasks can bring to the final objective. But these two tasks, between these two tasks, there is an exchange of forces. Think about when when two humans have to carry out a big fridge together. One is taking the fridge from one side, and the other human is taking the fridge on the other side. So both have to take the fridge to bring it, okay, or to carry out it. So there is an exchange of forces between humans in doing that, because there is a force and a reaction of the force. And this is the case, for example, of exoskeleton, when there is a measurement of the forces between human and robots. So this is not a collaboration, this is a cooperation, because there is an exchange of forces, and the robot can adapt on the basis of the forces. And the same can be done, for example, when we have a robot that can dance with a user. Think about a robot that can dance. You can understand that the integration, sorry, I will go a bit faster here. You can see that when a robot can dance, you can see, for example, that the robot has to collaborate. And this is the case of two robots that are cooperating between them. So there is an exchange of forces between them. So task 1, robot 1, task 2, robot 2, but two tasks are necessary, and there is an exchange of forces between them. And here you have the robot used for dancing, so in which there is an exchange of forces. So this is the difference between supportive, collaborative, and cooperative robots. Now we have the cognitive version, let's say, of the cognitive part. The cognitive part is much more related to let's say, those social cues that are present in human and that can be used, modeled also in the robot. Basically, what we do is that we have a model of the person, we have a model of the robot, and each of them, the people and the robots, have a specific mental model of the others. And then we have a model of interaction, and it is this combination that has to be achieved in order to perform a cognitive interaction between human and robots. And what are the main features? The main features could be, for example, as you can see in gesture and posture, like hand, posture, walking, facial expression, gaze behavior, focus of attention, prosody, turn taking, vocalization, silence, distance, sitting arrangement. As you can see, these social cues are related to specific social signals like emotion, personality, status, dominance, and so on. And these are the ingredients to create models of users, model of robots, and model of the interaction that there is between them from a cognitive point of view. Maybe we don't have too much time now to go much more in detail, but these are the parts much more socially, if you like. And here you can see an example of proximity. This is an experiment we did in our lab, for example. You can see a robot that was programmed to be introverts or extroverts, based on the proximity level of what we want to achieve. The proximity is basically the level of interaction, the spatial distance during interaction. If we are friends, we talk closer. If we are unknown, we talk a bit far. And you can see how to implement a robot that could be introverts. In this case, you can see the robot and user can stay together when they, for example, meet in a corridor during the day. But we can have also a more extroverts. We can have also a more introvert robots when the robots. The video is going, in which you can see here that the robot is programmed to work much more far with respect to the human. And this could be when the robot is not so friendly with the humans, or when there is not yet a specific friendliness between human and robot. So when the situation is more serious, the robot could be a bit more introvert, so more distance. Let's take the distance. When the robot has some confidence and friendliness, then the robot can walk closer to the user because there is much more friendliness between them. And this is a way to make a robot introverts or extroverts. This is one of the possible ways. This is an example. This is one of the experiments we did in our lab. And also for what concern gates, for example, we can have robots that can interact in a better way when they, for example, have to indicate an object to work with a human. So the head and the way they look at the object is an important information that they can be used to better interact with the human when they have to take in consideration, or they have to point one object that has to be used for cooperating or collaborating on a specific task. Okay. And the same is about the interaction rhythms. That is a typical. This is a typical situation in which we have to. The interaction rhythms is a part of the. It's a part of. What is included in the humans, because when humans are acting, are moving, they have a rhythm. Also, when we say hello, or also when we do any particular activity, we have a rhythm inside, and so we have to join. We have to join some specific. We have to do some specific aspects. So that's the situation. Okay. I will go a bit faster because I'm a bit in delay now with the. So when we talk about the robots, as I said in a previous slide here, models of people and models of a robot, what we have to do is to create this human model of interaction, robot model of interaction, and model of human-robot interaction. And this is the cognitive framework, includes a mental state, a mental model of the robots for people. So people have inside a mental model of how robots are and interact, and robots at the same time should have the same some models of how people act and interact. So the robot should have algorithms, for example, to recognize emotion, and the emotion could be mapped based on some theories, for example, coming from the psychology. And in this context, then we can create some model also of planning and of interaction based on collaboration, planning, and so on. Say that at one point we have also to consider another aspect, which is important, that when the robot collects all of this information, they have necessarily to take in consideration the capability to understand what humans are doing. So when if the human is walking, if the human is working, is manipulating object, is talking, is saying something, and what's how these data, which are in the perception layer, are used in this way. So basically, we have some specific sensors like a camera, as we saw, laser rangefinder, microphone, thermal camera, and so on. And the point is that the robot should be able to recognize what the user is doing what? Taking this signal, extracting some specific features, like for example, if we have a camera that can measure the skeleton of the user, then can extrapolate the X, Y, Z of some marker position of the skeleton, and then train some model to understand some specific position or some specific behavior, and so on. And then when the model are trained, to use the inference at the inference level, the algorithms to recognize, to detect things. So when we have a human activity recognition system, what we have to consider the signal, we have to extract features, we have to model the system with the training, and then we have to infer the activity using some. Let's have a look, for example, something like that for using the another work we did with our robot. So while the robot is walking with the robot, there is a camera that can measure, for example, the facial mimic for having some specific information about emotion. Okay, another also information about the posture and the way the robot is the way the human is working. And another as an example, another example is a robot that is following. Let me go. This is another cognitive task. Is a motor cognitive task that is used in cognitive impairments and in Alzheimer's disease. And we have a robot here that is measuring how the human is doing his job, and is also measuring in a precise way the gait analysis of the human. So this is a robot that is measuring everything, and it's following the user for performing the object. So the robot is an assistant to perform the rehabilitation or the assessment or the cognitive task, but it's also an assessment tool for decision support system. And at the same time, we have other robots that we use to recognize gesture. For example, if the user are doing specific tasks that are asked to do, like drinking, heating, cleaning, and so on, or if the user are doing a rehabilitation task like dance task in rehabilitation, like this one, you can see we can extrapolate some data, or also using some other sensors here, just to give you some example of some sensors that can be used in combination with robots. This is the case, for example, of Parkinson's disease. These sensors will be also integrated with the robots for measuring most of the example that I showed you before. Sorry, the video is a bit slow today. Probably it's too hot, and the processor of my computer is a bit complicated. Okay. Okay, so these are some examples. Let me give you just two advertisements. If some of you are preparing papers, we have a special issue in robotics, which is about human-robot interaction. And we have also a conference in Florence in December. It's the International Conference of Social Robotics. So if you like to attend, you're free to attend, presenting a paper. And that's all from my side. These are our robot, our lab. Thank you.
Thank you, Filippo, for your speech.
I don't know if you have a question.
Yes, exactly. It's time for questions. And in any case, at the end of this day, they have to, if they want, they can get the learning test. And in case, if you want to stress something about this, Filippo, you can go ahead in case, okay?
About the test, the final test.
Yes, exactly.
Okay, yes, there are some important points that you have to consider. These are when we develop these robots, the first thing from an engineer point of view, we need to have robots that are dependable. This is the most important thing, because if robots are not dependable, they are not able to work, and it's a problem for us. And dependability can be measured with the safety, availability, reliability, maintainability, adaptability, and security. This is very important. And please don't forget also the fact that robots are not alone. Robots are always connected, and are connected in a way that Internet of Robotics thinks. So the concept of Internet of Robotics is very important. So we have a number of systems, distributed sensors, and so on that are combined between them to generate intelligence. And this is an important point. Again, consider that when the robot can interact with humans, can give different kind of support. So the interaction can be supportive, collaborative, and cooperative. So when you know about cooperative robots, it's not everything. There is also the supportive and also the cooperative. Okay, so these are some important things that I think it's important to consider. And in order to be much more oriented to clinical application, to biorobotics application, I think this is important, that the robots can be used not only for interacting, but also to have a specific clinical application. Okay.
Okay, thank you, Filippo. Yes, we have questions in the chat now. And the question is, it's coming from Faiz, who is asking how robots work in GPS-denied environment, like underground areas.
Oh, yes, in that case, the GPS is not available. Usually the robot can use the laser rangefinder, which is here, as you can see in this, maybe I can show you this one. Where is my slide? Blah, 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 blah. This one. As you can see in this video, the robot can be instructed to have a map of the environment, and then using the laser rangefinder can localize with the laser rangefinder and can generate the trajectory. So we don't have a GPS. However, there are some other aspects, other technologies that can be used in a similar way like GPS, but today are not so much used. And are the wireless sensor network that, based on the power of the network, can act like a GPS. So basically, we can have sensors in the environment that can measure the position of the robot or other objects and humans in the environment. Okay, but without GPS. Okay,
thanks. We have another question, Filippo. What machine? Yes. This is coming from Adriano Scibilla, and he is asking what machine learning techniques do you prefer for human intention estimation? Are deep learning techniques such as neural networks good for recognizing a normal human action from an unintended behavior caused by an illness, or they lack on knowledge about physiological background?
Okay, very interesting. My opinion is that today, and this is also what we are working, so I don't have a specific answer. This is the solution. We are working on that. But my guess today is that we need some architectures of machine learning algorithms. And what does it mean? It means that we need for sure some supervised approaches like neural network, or if you like also deep learning, to clusterize some features, also to recognize something. But I think that this should be, above all in intentional estimation, I think it's interesting to connect these or work with these techniques, these supervised techniques, together also with some other approaches like the reinforcement learning. I think this is now what I see in the literature, and this is what we are trying to do as well.
Thanks again. We have another question from Giulia Masi, and she's asking, hello, thank you for your presentation. I have a question. Which ones are the advantages of using a robot in healthcare setting? Which are the main application? Because like for gait analysis, there are many alternatives.
Yes. The point is that we have, it's true that we have several alternatives, but we are going in a direction to have different environments that can be used. We can use technologies in different environments. Just to give an example, gait analysis is a typical test that is performed to assess the level of pathology in Parkinson's disease. Okay, of course, a patient with Parkinson's disease can go to the hospital. And then can use any device that is typically used for that without the necessity to have a robot. But think about Parkinson patients that could need assistance at home, can have a robot at home. This is the future, of course. And imagine that the robots, in addition to provide assistance, can also acquire those signals that can generate clinical data that can be sent to the doctor in hospital. So that let's say that the robots could be something that can enhance, that can generate much more elements related to the healthcare application, and generate more elements for diagnosis, therapy, adaptation of therapy, and so on. And also in rehabilitation, think about that when you are in a rehabilitation center or in an hospital, the robots could be one way also to have a one-to-one assistance during the execution of the exercise. Sometimes this is not possible because we have one operator and several patients. In this way, we can have one operator, few robots, and several patients, so the operator can be assisted by the robot to follow the patients.
Okay, thanks again. We have another question from Usama Rashid Qureshi, and the question is, any applications in Friedreich ataxia or similar symptoms?
Oh, yeah. Honestly, I don't know now about that. Honestly speaking, in my experience, I have not yet found something for that, to be honest. But maybe I can check and I can find something.
Yeah, it's something really specific in this case.
Yeah, it's very, but I think it could be possible. Above all, if this ataxia or similar symptoms can use those of the features that are typical of the social cues.
Okay, so I don't see other questions. So at this point, I would like to thank you again, Filippo, for this really interesting lecture. And at this point, the first part, the first lecture is over. Now we have a break of 10 minutes. And so this means that at 4:40 we will start again. So please be in time 10 minutes from now. Okay. Thank you.
Okay.
Thank you again, Filippo.
Thank you to everybody. Feel free to write me for any other question. Bye-bye. Ciao.
Thank you. Ciao, Filippo. So 10 minutes break.
Ci siamo.
So it's time to start. Massimiliano, are you here?
Yes, Andrea, I'm here.
Okay, thanks. So it's time to start. Okay, now we have the second lecture of this day, and this lecture comes from the engineer Massimiliano Malavasi, and the topic is examples of applications of AL solution in the activity of an AT center. So let me to introduce the engineer Massimiliano Malavasi. Massimiliano is a biomedical electronics engineer. is the head coordinator of the CRA, the Regional Center for AT, a regional institution in Emilia-Romagna, Italy, specialized in technologies aimed at improving the quality of life of people with disabilities and elderly. The engineer Malavasi is also a member of the multidisciplinary team of CAAD, the Center for the Adaptation of the Home Environment in Bologna. His research activities include assessing, designing, and integrating advanced technology, assistive and active solutions, domotics, healthcare technologies, and social robotics. Engineer Malavasi is also in charge of We Care More Center for Research and Innovation as Senior Researcher and Project Manager. This center is active in national and international research projects, including SHAPES, ICT Technology for Healthy Aging, Plain Air, Smart Parks, and SEORE, ICT Solution for Integrated Care. So it is my great pleasure to have here the engineer Massimiliano Malavasi. So, Massimiliano, the floor is yours, and so you can start with your lecture. Thanks. You can share, of course, your screen.
Okay. Many thanks, Andrea. So just begin this lesson that will be, I hope, also a dialogue with many of you. So just let me share my screen. Okay. So I have to sign and optimize for video. Okay, Andrea, can you confirm that you all can see?
You are not in the presentation mode.
Okay.
But, okay, so this means that the slide is smaller than, yes, exactly.
Okay, okay.
Thank you.
Okay, thank you very much. So just go directly to introduce what we will talk about today, this afternoon with all of you. And we'll try to put, our hands in the field, because the main aim, the main goal of my intervention in this summer school is to show to all of you, AIAS solution really implemented on the field. So, you know that provide and implement this kind of solution in a real environment, in a real situation, could be really complex. So you have already seen and will see a lot of edge and cutting edge technologies, research project, and so on in the summer school. But I'm here to show you some way and some, of course, problems but also challenges to implement this solution in the real world, and of course in a healthcare and social services and so on. Of course, as you know, AIL is a very wide field, so I needed to have to make a choice, and so this afternoon we will concentrate on mainly on smart home solution, domotics, and technology to adapt home environment. Of course, this is a very, very important field in a health sector, because it's connected to the possibility to keep at home elderly people, to improve quality of lives, to better support people with disability in independent living, and so on. So this is a very important field, and designing the program of this summer school, we decided to go exactly in this direction. So, what about this kind of technologies? Well, one of the most important point of solution for making smart environment and like home automation system, like, I don't know, IoT solution, is that are really flexible and scalable and can be connected in a modular way. This is very important in the real world, because of course it's not so easy to make full home automation, smart homes, because of course this means changing a lot the environment of the real environment in which people live. And of course, there's many costs in this very huge, very high level of adaptation. So one first take-home message is that reason in a very modular way could be a really positive point for implementing this kind of solution in the real world. So historically, environmental control is a definition of assistive technology that is more or less focused on single devices, single applications, so very small adaptation, but for very specific need of people. So one problem and one solution. And this is the base level of home adaptation. And then we can call this basic domotics. It's sort of light adaptation with more devices connected. So this is already domotics, this is already home automation. And for example, we can go for, for example, again, focus needs, but adapting in a wider way the home environment. And then we have, of course, full smart homes. And in these cases, we go for a completely adaptation of the home. We go for connecting several devices, several systems. And of course, these kind of homes are also always often connected to remote services. And services is a key word for the next level that is already not so much implemented in real world, and is what we can call in this school AIAS services, because we all know what we are talking about. Okay, so this is, as I said, is really important because we can give the correct solution. We have the right intervention of each specific situation. Okay, and so of course there is a lot of taxonomy on classification on smart homes. This is one that I like a lot because it put the focus on the connection and on the intelligence of the system. So it was it came from Aldrich in more or less 20 years ago. So it's quite interesting that in that year people was already reasoning on this kind of solution. So again, the idea is to have single object, smart object, and then begin to going in a higher level of home automation, connecting more objects, and then try to connect home with low remote services. And this is where we are now, more or less. What is really important, and the big question is, are we able to go in for the fourth and fifth levels in Aldrich classification? So having this kind of, homes that are able to analyze the pattern of activities and manage appliance according to this analysis, or just, for example, coming to attentive homes, and they also, in this case, define the possibility to go in anticipation on human needs, so in order to provide adaptive cues for human occupants. This kind of technology, we know there is a lot of research projects that are already working on this kind of solution. Of course, we have artificial intelligence, big data analysis, learning system, and so on. But of course, in real world, these systems are still considered too often prototypes. Okay, so this is what we will focus today. The at the actual stage, the technologies that we have are often in the fields very traditional solution for home automation system, but there are already a big improvement in comparison with traditional electric plants of home, for example, of elderly people. So the idea is to begin to connect several appliances, several devices to connect with a data bus. We know that sometimes it's based on cable, sometimes it's based on a wireless solution, but this is a big step forward, and this is still a step that is not easy to provide, for example, in very old buildings, in very old homes of people. Okay, but what is really important by point of view of assistive technology often is to work on human environment interfaces. So on one side we have users, on the other side we have environment, and of course the environment is made by daily life places and a lot of function and services. The first barrier, the first challenge of assistive technology is to make it possible for users that are not able to manage this function and service to access to them, to be able to use, to access, to and of course do this kind of things in an independent way. So the first step, very important step that is also sometimes very challenging, is to work on user interface. User interface is a key factor on AIAL solution and services related to home adaptation. Sometimes we still have some counter solution, for example, from the wide market, but sometimes we need a very special solution, for example, special input, special output, to make it possible to link these two kind of level, person, user, and environment. And sometimes this is not so easy to do. But what is happening now is the evolution of IoT, of Internet of Things, and cloud services. So assistive technology is really changing also in the, as is happening in a wide market ICT, in the ICT wide market, we have more and more assistive solutions that can be connected, that are based on IoT paradigm, okay? But what we have to do is that, for example, smart home IoT devices, if this is the data that are not so recent, but are still very impressive. We have more than 1 billion on smartphone IoT devices 3 years ago sold in the market. And for example, we have very, very few, of course, are not so few, because we are talking about 100 million more or less medical IoT devices. So this is another challenge, the mix of specific devices for specific needs and wide market solution, okay? And we need both. And this is again a challenge, because on one hand, we have a specific solution designed for elderly people, designed for disabled people, and on the other hand, we have a lot of possibilities that come from the wide IoT or in general electronic market. Okay, and of course new challenges, because if you think about assistive technology of 10 years ago, we didn't have so much problem about I don't know, personal data, because they were not connected devices with I don't know, for example, personal profiles or something like that. The assistive technology solution don't get data from the person, from the users, and so new challenges also on this side. Okay, so what we are expecting now, of course, IoT is more or less the next challenge, but also give a lot of opportunities. So we are going for a sort of massive IoT ecosystem. This comes from a very interesting report from ISTAT, that is the Italian main institution about statistics and analyze for present and future and so on. And as you see, there are several ecosystems that will have a big transformation about IoT, you know, smart city, public enterprise, transport, logistics, agriculture, and so on. But people will be a very important part of this transition, okay? And you see also in this wide vision report, the idea to have wearable sensor, to have child tracking and healthcare monitoring is considered something that will be really important in next year. Okay, and which are the mission critical IoT context? You know, again, there will be medicine, so AIAS, life critical biomedical sensing and so on, but also person object interaction that are also really important for people, for elderly people, for people with disabilities. So also in this big vision, general vision of what is happening during next year's AIAS solution are considered really important, like for example, the transition in automotive that we hear all days, quite a very critical transition. And what about the implementation of services based on IoT in a healthcare system? Okay, here you can see a sort of very general framework. Of course, IoT are again very flexible. We can decide to do the things in a different way, but here we have some part of a general IoT system that could be considered really important. So, of course, we have to do decisions. For example, should we connect our IoT device for AL application directly to the network, or perhaps using the mobile device as a sort of a gateway, or implement a specific gateway for devices and services directly in the home. Of course, there are some pros and cons on each solution, and by point of view of a research project, of course, we can go for the best performance with what we need as the best solution for the technologies that we want to develop. But when we go on the field, of course, there are many parameters and many needs and many contextual factors to analyze, to do the best choice about these possibilities. Okay, so just to end this first part of my speech, what we are facing now by the point of view of social and healthcare services, that we are going toward a fast paradigm shift. For example, in AT market, in the market of assistive technology, we are going from single device to services. And this is a very big transition. This is a very big challenge, because as I said, we can just think that 10 years ago, the assistive technology market was based on single devices. Things are changing very fast. And of course, all these connected devices, all these connected solutions, all these remote services are shifting again the focus on single users, that of course is still really important, to communities. Okay, and of course the paradigm of social network and so on could be applied, as we know, also to AL services, just to do an examples. And this is again a very important change of vision. But also we have, as technicians, as people that are working on research and development of new solution, we are facing this very big challenge. And that is, should we work on a specialized solution for specific need, for specific user, for example, using medical devices, that kind, for example, of certification, that kind of performances, or should we go for a mix of wide market solution and specific solution? Of course, in this second case, we have the possibility to give more options to our user. And so technician and expert in AI solution should do a lot of work to understand when we should use only very specific solution, for example, as I said, that need a medical device certification or something like that, or when there are the condition to make people using wide market solution, like for example, an app with a smartphone, a tablet. And of course, this is important. This is important in home automation system. This is important in domotic systems that we know have a specific market. And sometimes, for example, there is some specific user interface developed for assistive technology for specific disabilities. But it's also the same on very specific application, again, like, for example, localizer that use satellite position system that we can, for example, do very effective solution starting from wide market solution. Or we can go for defining very specific solution. Okay, and this, as I said, happen both on this, general purpose system and both on specific or system designed for very specific need for very specific context. Okay, so of course, to many of these questions, there is not only one question. What we should do as a community, as single researcher, as specialists, as technician, and again, is to understand which is the best way to use all the possibilities that the technology is putting on the table. So the second, then we can go for the next part of my presentation, and the big question is, how can we provide these technologies, these devices, this service to final user? And so I will describe you some options. I will start from the center in which I work. I'm part of a third sector organization, a non-profit organization that's called AIAS of Bologna province that have developed this and a specific team on AT and now AIAL solution since the beginning of 80s, the golden age of personal computers and so on. Because in that years, and we are talking, of course, of more than 40 years ago, there was the first big development period of ICT-AT, okay? And actually, this team is divided, is managing 3 assistive technology centers. The first one is, and the most recent one is Wickermore, that is dedicated to research and innovation in AT and AL, more or less is an applied research center. And the second center is the Regional Center for Assistive Technology. And the main mission of this center is to support final and professional users on assessment and implementation of assistive and AL solution. And the team is also managing a specific center dedicated to home automation. It's a part of a regional network, and there are many other of these centers to support direct to final user in adapting their homes. And one of the most important things is that all the centers are operating with a multidisciplinary approach and multidisciplinary team. And this is essential to provide correct information and correct activities to final users. So, of course, another very important thing is that not to work in a self-reference way. We need to be part of a big vision. We need to share our experience with other centers and so on. So we are also founder and partner of the GLIC network, which is the network of assistive technology independent assessment center in Italy. And now we are more or less 24 centers, and we also have 3 big scientific partners. So this network is very important in Italy, but I mean also in Europe and at an international level, because we need to work in a joint version to share experience, to share protocols, and sometimes also to share research and in modeling of intervention. Okay, provide a TNLL solution is a very big challenge. And of course, we also have a lot of very big opportunities. The big problem for people who are working in this field is that many literature articles and research activities show us that more than 1/3 of the IT solution provided worldwide is abandoned or not properly used. And so the big question is why? Because there are a lot of solution and there is a lot of failure ratio, okay? And there are many reasons for this kind of thing, situation. And the most important one is that we should work in the proper way. So, for example, improving quality of life of people with disabilities and reducing activity limitation, improving participation, and improving the quality of life of caregivers should also be our really important main goals. These are the opportunities, and we need to be focused on this kind of way of thinking and operating. The IT service delivery that we can, of course, use the ATSD, refer to the broad set of processes that serve as mediators between the person with disability or the elderly person and the proper IT or AIAS solution. ATSD varies broadly. We have to be aware of this within and between countries and may vary in relation to each country's disability policy, socioeconomic context, and the histories. But there are some very important general themes that are valid in any system, okay? So, of course, these are very big issues and very big topics, so we can talk for days about this kind of problem, but the second take-home message could be this one. These are the 5 important and general steps of a good IT service delivery process that could be also applied in a good condition also to AIAS system. So there's the initiative. When all the process started, there is a need. There is something to do for one specific need. And the second step is a very good assessment. This is a key point. And after the assessment, there is the selection of the proper solution of technologies. And there is another important phase, complex phase, is the procurement and implementation of the technology. And one important thing is quality, to control, to check what is happening after. And so the management and follow-up of the solution. It's a circle process. And of course, sometimes we need more than one step. But these are the 5 pillars of a correct AT and AIAS service delivery process. Okay, let's describe briefly the 2 centers that I have cited before. The Center for Adaptation of the Domestic Environment, that is called CAAD, can give some information about, for example, regulation, funding, possibility, and so on. One of the most important activities is assessment and consultancies. So, for example, about architectural barriers, domotics, accessible furnitures, ADL adaptation, and so on. And this center can go on site on the real homes. And also this is quite a key factor for success. It's also in Corte Roncati, that is the building from which I'm talking to you. And we have a lot of facilities and tools to make better assessment. For example, a permanent AT and AIAS solution showroom. And there are 2 domotic smart homes that are fully equipped with a lot of solution. There's a documentation center and the possibility to make integrated assessment with other specialistic and clinic centers. So the idea, the key word in our daily activities is compatibilities. Compatibility between person, environment, solution, and legislation. And sometimes to make all these 4 contexts compatible is not, as you can imagine, a simple task. And it also implies some strategy to get the correct solution and, of course, to implement it. The CAD CAD is a so-called first-level services, and which means that the individual citizen can access directly to the center, but if, of course, also professional, formal carers, and professional, for example, for social community level service can also access to the center and work together with multidisciplinary team that you can see. There is one social assistant, one educator, one architect, 2 engineers, and 1 occupational therapist in the staff, okay? So the other center is the Regional Center of Assistive Technology. Let's have a look at the possible activities. This center can provide direct activities, for example, individualized paths to support people with disabilities and their context of life and care. But this center could also provide indirect activities aimed at the levels system of healthcare services professional at a regional level. Just to give you an idea, Emilia-Romagna region have a population of 4.5 million. So a quite wide audience and a group of possible users. And for this wide range, area, we should give information, updating about edge technologies, research and development, support to specific network, like for example the network of CAD centers. We can support schools, university about assistive technology and so on. And again, all these activities are carried by a multidisciplinary team. This again is a key factor. Also, the direct service to single user could have some different intensities. We can give some information or orientation we can identify, have a specific assessment of a specific assistive solution. And we could also give some support on a specific case direct to end users or perhaps to carers, to professionals and so on. We can also provide the loan of some technologies. And again, we should provide follow-up and outcome analysis. Of course, there is some limitation in the access because this kind of services are paid by the local health trust, and so there is some protocol that and some limitation to the possibility. For example, one person could have from 1 to 4 intervention on a specific on a single needs. So we can give a first evaluation that, of course, for example, analyze complex questions, complex needs, and so on. And we have a lower intensity access that, for example, is the evaluation, because the condition of people change. Or, for example, the current solution is no more usable, is no more efficient for that person. And at this level of complexity, for example, we can give a loan of complex aids. And then, of course, there are the type C assets that have a lower level of intensity. And we have also a fourth level that, for example, are support to users on thematic technical issues, for example, and they require only one operator. So at this last level of intensity, we don't need to work as a team, but one single operator can support people on that specific needs. As you can see here, there's a lot of context and possibilities and need on which an assistive technology center can intervene, can give services. For example, we can work on different environment and context: home, work, school, daycare center, residential center, sport. We could work on different solutions for daily living, for example, environmental control, simple aids for ADL, transfer, lift people. We can also work on different kind of technology for mobility. One very important and complex field, for example, is power mobility, electronic wheelchair. We should work a lot on tools for communication, security, and integrated care. For example, supporting people in alternative and mentally communication pathways. These are very complex technology and system. And another big point, very important sector is the access to ICT technology on tablet, on computers, on software, on social media, and so on. And again, another important field is innovative technologies, because often healthcare system could not work a lot on new technology. They don't have time, they don't have specialists to implement new technology directly on specific healthcare service. And so they need help. They need help for a center that have the competence, the specialists to work also this. And this is why an assistive technology center should also make some research project or should be updated on cutting edge technologies, because implementing new technology in the healthcare system, of course, is really complex. Okay, so let's go for some case studies. Of course, providing technologies is quite a complex process, as I said, but we have only 1 hour and a half, so the best things to do is probably to go and see some application or solution. The IoT per il Sociale project is quite interesting, because the idea is to work on new technology, like for example, LoRaWAN, that you know is a low power and wide distance connected system, and which were the main goals or are, because the project is still going on. The main goal is monitor elderly users living at home, and one of the most important and challenging specification is that the possibility to have no need of internet connection. Of course, this could be a problem. And so for this specific, specification goals, the idea is to use, try to implement technologies that could use low power and low cost technologies. So which was the solution and component selected? The idea was to use LoRa-based standard devices. LoRa is a standard for low power and wide area network. There is an alliance composed by many providers and device providers. And another very important infrastructure was the so-called Rete per IoT that was established by Emilia-Romagna region when the administration of the region decided to make this very big LoRaWAN-based regional network. And of course, we also need a way to connect this sensor to place in the house of people, to the cloud services. So another important resource was a SensorNet, that is a regional-based cloud services for acquiring data from the sensor on the field. And what was missing and what we should have to develop was a completely new and easy-to-use dashboard for carriers. And of course, selected a very easy-to-install sensor set. So The methodology. The first very important part of this methodology was to use to apply a UCD process with the different actors of the experimentation. So then we begin to do a lot of friendly trials and internal technology testing, because this LoRa-based device was quite new. It's quite a new technology, and of course we have to understand well which was, for example, the reliability of the connection with this very low power and wide area network technologies and devices. And then the third step was involvement of different actors to verify the first demo site. And the next step was a further development of the solution according to previous step outcomes, and of course coming to first installation. And again, very, very important by the point of view of final users, that you have to train the carers that, of course, was not aware of the possibility of these technologies and never have had the possibility of use this kind of solution, dashboard, and cloud services. So the first installation sensor kit was composed by, well, had to be very little invasive, with a very long battery life and low need of maintenance. The data acquired was temperature, humidity, brightness, and to have some information about the behavior of people, the data of presence and about movement. So when we come to design this dashboard that should be used during days, during months, and during years by the professional carers, was to the main aims was to monitor behaviors and manage alarm signals. And we should give the full awareness, the full training to people that these are two completely different things. So a simple way to guide the monitoring of parameters needed to support the case. The question was, when I begin my service, where do I need to direct my attention? So the final solution involved a very simple user interface with simple icons with different colors. In this way, the consultation could be more intuitive and faster. So the idea, and this is a key factor, the carers should not spend more time with the new system, but simply optimize it. So, of course, the data analysis by the professional caregiver can, of course, they can immediately discover with these smiling faces if there is something that is going wrong or just is different from the usual lifestyle of people. And the medium long-term analysis and the comparison of the data collected over different periods can help understanding possible changes in behavior. And for example, a new activity, a new way of behavior that could be signal of something that is going wrong of the health state of that person. So here we can have some screenshot of this. For example, could be a problem because the system have detected 6 night movement inside the home of this person. So perhaps this is not so good. And we could also make an analysis in the week time, of course, in this way we can see if I mean, more or less the behavior of people, for example, during night is correct or something is changing again. And this is again an example of regular activities. For example, in this apartment, there is only 1 night movement. So we can consider this as a regular behavior. And again, in this screenshot, you can see a very regular behavior because we have 1 or 2 occasional night movements. And so nothing to report by the point of view of the system. Okay, so what is the main message about a system like this one? Okay, we have a new technologies and we have selected that technology because it could give the answer to our specification, to the needs of these local services. But we need to keep very, very simple the use of the system, both by the users. In this case, was a completely passive system. So elderly people have nothing to learn from the system. They was made aware of the new system, but nothing more. And the dashboard need to be extremely simple because there is no professional care that have been completely dedicated to this analysis. They were the same, they are the same care that was in charge of having charge these users, and so we don't need to give, we should not give her more, burden daily activities. This is a very important part of the game. Then I can, as a second case study, I will show you some two very small projects. The name of these two projects are Moving Out and Care at Home. This is the leaflet to involve that we make to involve possible user. Of course, it's in Italian because it was implemented in Bologna. So in this case, the idea, the big question is, can we use wide market solution, like for example, vocal assistants, smart speakers, and wide market, smart sensors, smart bulb to support elderly people. So we involved in this project more or less 10 users, and the idea was to provide care services in the remote mode, starting with very cheap and very simple technology. And but in this ways, we can remain in contact with disabled and elderly users that was alone at home. So again, we chose to develop a very simple user interface and to use local cost mainstream IT technologies. And one important point is that COVID-19 emergency was a key factor to enhance this kind of service. We work on this small project because we were requested to do this kind of thing by the local social services. So again, pandemic emergency was a very tragic event, but also was moved something in the mindset of decision maker on social services, and many of them have learned the lesson, and the idea of implementing technology-based services now is considered as a real challenge and something that should be done. Okay, so again, what we learn, what was the lesson learned from this very simple project? The idea is that we should always proceed with customized pathways. So standard kits and something like that is sometimes not the best solution. In many AIAS services, the possibility to customize the service is a really important thing. And we can use light home automation system, IoT solution, devices that come from the wide market. Of course, we should be really aware of the limitation of this kind of approach, okay? And the impact of this technology used in this way was really positive. But of course, there are some key points, like for example, the importance of a digital infrastructure to overcome the digital device, because many homes of elderly people are still not connected, are not so simple to connect. And for example, there are some costs associated to the idea to make this internet connection at home of people, and sometimes people aren't able to pay for it. Who pay for it? A big question. Okay. And of course, using these wide market services have also not only positive points, but also some challenges, some negative points. For example, managing the privacy issue. Okay. And then timing is going fast. So let's come to the final case studies that is related to a full smart home. So I will show you now a video just to relax a bit. I have selected audio, so probably you will be able to listen to what this user is saying, because this video was made by the final users that have decided to implement, supported by IT Center, a full smart home.
Clock. Svegliarsi. Global. Apparecchio. 1. Go. Accendere. Porta. 4. Apri. Abbiamo cercato le soluzioni architettoniche e domotiche più adatte alle mie esigenze dal lato architettonico, coinvolgendo un mio caro amico architetto, e dal lato domotico e tecnico ci siamo rivolti al CAD di Conte Roncati. Da lì la mia vita è decisamente cambiata, perché mi sono veramente impossessata di tutti questi strumenti che fino ad allora io non conoscevo minimamente. Global. Apparecchio. 3. Go. Accendere. Attualmente non vorrei assolutamente cambiare niente della mia casa e vorrei semplicemente continuare a scoprirla e a scoprire i regali che la tecnologia può fare anche in caso di handicap. Clock. Svegliarsi. Luce. 4. End. Spegnere.
Okay, so I think that we can see this case as a success case. It's really interesting seeing Valentina that is explaining to all of us how important these technologies, this AT and AL solution, have changed her life. But of course, to arrive to this final goal, she needed to have a lot of support, and there were a lot of steps, one after the other. And it was a long-term AT assessment and support stories. For example, when she was very young, the first step was to have a full access to ICT solution. For example, she began to use one video virtual keyboard, a mouse emulator, a word prediction software, and 5 buttons as an external interfaces. And then the next step was to begin to control her environment. She began to use a scan access AT remote control. This modality, I don't know if you already know how this is work. You have an external sensor that is more or less could be, we can use different sensors, but often we use a very simple big button, and the user can press this button and the remote control the system have this scanning during time of different options. For example, the different channel of television, and you go for a single movement, a single pressure of a single button to select the correct option. Okay, this is quite slow, but also require very low effort, and of course is something that could be used in motor disability like the one of Valentina. And then she decided to go for a third step in the implementation of assistive technology in her life. And she returned with this main goal to our centers, and she had decided to go and to try to live independently. So the idea was to have a complete renovation of a home. The layout of this home was really interesting because it was an open space, and this is a positive thing by the point of view of accessibility. The principal needs and goals was to obtain the maximum autonomy during daily life, but also have a nice home. So aesthetics was a key point for her, and of course have comfort, like all of us want to have in our homes. The areas of intervention of interest was, of course, domotics and home automation, accessibility, safety and security, and of course, you saw how was important to implement a correct user environment interface. So, by the point of view independence, going more in deep about this point, there was a need to have internal, external, and remote communication, to have an increased mobility and accessibility, the access to ICT application in a new and more efficient way, the use of domestic devices and application, and of course to have the possibility to control many environmental factors, for example, the climate, the lighting, and so on. But another very important point was safety and security. So, for example, the possibility to handle in an independent way small and big domestic inconveniences and have an independent communication in case of emergency. So, this is more or less a detail of the layout of the home. So the idea of have this open space was a really good thing. And so which solution, AAL and AAT and home automation solution was implemented? There was a need of a complete integrated domotic system based on KNX standard. And also Valentina decided that the scan mode remote control was not so efficient to control a whole home. And so he decided to shift to a voice remote control system, but of course was a complex step because we need to select a remote control that was able to understand her commands, and she also worked a lot to train her voices to have a good performance with that kind of voice control system. And again, she decided to keep the remote control with scan mode as a sort of emergency solution. For example, if for a flu, she could have problems in speaking correctly the commands, and the completely hand-free based on RFID technologies, keys to enter and exit from the home, an accessible telephone, video entry phone connected with TV and accessible telephones, motorized awning and curtains, windows and doors, a remote alarm, of course, a lot of accessible furniture, and an anti-theft system. So here we can see some photos, some details about the system that was implemented. So, you know, a very complex adaptation. And of course, we implemented together with Valentina advanced function to better support her independent living. So for example, night and day and in and out scenarios, entertainment system accessible, light and climate management, awning and doors management, emergency management, the voice control system, the one just to scan mode and environmental control, external secure control, access control, and home security. And you can see here how the home is, I mean, nice, I like it. And I mean, also this goal to keep the things nice, to have this attention to the aesthetic characteristics was accomplished. So let's try to analyze anyway this specific case studies. Which was the key factor for success? The first one is to always use a user-centered approach. So the user should be at the center. So we have to analyze the motivation, the need, the wishes, and the preferences of the users. And this could help us to reach the goal of this empowerment and to keep a very high quality of life. And we know there are many dimensions to consider in the correct selection process of AT and AIAS solution. So another thing that the users usually need to have is an adequate support. So let's see some characteristics of this adequate support. Independent advice. So there is someone that is there to make assessments, there to be a designer with no commercial interest. We always need a multi-professional team to support this very important, these big pathways of independent living. So engineers, occupational therapists, education, all should be specialized in AT and AL. The continuity we need to support the person in all her pathway, his or her pathway to reach the goal, holistic and long-term perspective, and a step-by-step approach. Okay, so there is the need to incorporate independent AT and AIAS resource center with similar intervention model in regional service delivery or in general local service delivery system. Okay, this is a screenshot. This is a possibility. I said there is the regional center work at the regional level. There is another specialistic center that work on, for example, architectural barriers. And this second level regional center could support the first provincial center, the CAAD. And this network that was implemented several years ago in Emilia-Romagna region is working very, very well and could support in a good way a lot of final users, but also a lot of social and healthcare services. So in case of Valentina, the idea is that there was an area assessment to focus to where we should go, to focus the philosophy of intervention. And of course, multi-assessment support to personalize the smart home project. This was also very important. Activities of training in our demo smart homes was also very important because we can manage. She can test herself in a smart home before implement this solution in her home. The contribution to the design phase, the assessment of public funding, because this solution cost, of course, this could be a problem. Support during installation and configuration phase, and also support in the startup phase, for example, user training, fine-tuning of the system, personalization. Also, this post-implementation phase is really important. Okay, and let's go, before conclusion, to the first topics of my speech, that is the outcome measurement. Sometimes it's not so simple to evaluate the outcome of AT and AIAS solution in real world, because of course, when we are following a specific methodology in a research project, we are very focused on specific aspects, and so we can evaluate quite an easy way in this quite, restricted context. But when we go in the real world, it's not so easy to understand which is the real outcomes of a smartphone in the life of a person. Okay, so now I will describe in this last slide to the methodology of the studies that we conduced as a Regional Center for Assistive Technology to evaluate the outcomes. So the first phase was the selection of tools. So this was very critical. And the review of cases in a period of 2 years, the definition of samples, representatives for area of intervention. As I told you before, we work in a lot of areas of intervention, and of course the analysis of results. So we decided to use this SKY, that is called SIVA cost analysis instruments, that is really interesting, was developed for a single IT solution, but we try to apply to full home adaptation, because these tools could have be used both on a retrospective point of view to assess the impact of a chosen solution, and also by a perspective point of view to support the choices when different solutions are available, including the choice for non-intervention. That is still an option. So the study was conducted to compare the comprehensive social costs, that are a lot, generated by technology-based solution, and to compare this with what we presume is the situation in case of non-intervention. So, of course, like in many economical tools, we have possible expenditures that refer to a financial transfer, and cost refers to economic value. So the big important point of SKY is that the concept of social cost, that refers to the sum of all resources with an economic value that is engaged in sustaining a situation. For example, technologies, procurement, installation, use, maintenance, human and care system, and this is a big cost in many of these cases, environmental adaptation and others. And of course, what is defined by these tools is the additional social cost, that is the difference between the social cost following intervention and the one in the case of no intervention. Okay, so this analysis come to define, to acquire a lot of data, and one of the most important points, for example, in the case of Valentina, is that with the smartphone, she actually needs only 3 hours per day of assistance compared to the 13 hours before intervention, and this every day. So the idea is to work in a very similar way that people do in, energy saving investment, something like that. And the result is impressive, because in a 5 years perspective, there was a save in social cost of 300,000 euros. And this is an impact that is very, very big. So she is able to have a very good quality of life, but all the society as a whole, starting from herself, from her family, from informal care, from formal care, for social service. All this could save a lot of money, a lot of effort, and of course, have a better quality of life also for these actors. Okay, so I mean, we can agree that this kind of saving is by far more than the one that, for example, we can have as a society in energy saving activities. Okay, so we can have a big impact of this technology, and we can demonstrate this positive impact both on quality of life and on better cost, saving money. Okay, so let's come to the conclusion. The impact of AT&AL solution on independence and safety of a person in his learning environment can be very high. Impact is not only demonstrable in quality of life, but also in efficacy and cost effectiveness. And factors of success include user-centered and user-led processes, adequate formal and informal support, and of course, integration of different resources. Independent assistive technology and AIAS centers can facilitate and guide the actual transition of social and healthcare services. Again, the AIAS solution and services, like the one based on smart homes, are constantly evolving and allows to take advantage of new opportunities for care services. Implementing this solution is a complex process and requires multidisciplinary skills, but we can all take advantage of the good experience gained in the AT sector. This is a very important experience. If in the early years, smart homes made it possible to support many independent life projects for people with motor and sensory disabilities, today the smart home community is increasingly working to support people with intellectual disabilities and frail elderly, a big challenge. Connected technology allows for implementation for smart home, always connected, and this allows to provide remote services even 24 hours a day, 7 days for a week. But to take advantage of all these opportunities, it is necessary to integrate the AI solution and approach into our care services. Redesign is a big challenge in the more general framework of the digital transition. It is important to train care services professionals in this new solution without increasing their workload, again, very important, but rather allow them to better support users, also benefiting them in the daily organization of care activities. And this is the conclusion of my speech today. I'm talking to the very good researchers. Please don't invent the wheel again. We can build new service, new research, new solution on what is already done. Okay. And sometimes some research projects seem to reinvent the wheel. This is not the good way to do things. Please stay in contact. We have to reason as a community and go forward because there is a lot of needs that are still not covered. Okay, so thank you for your attention. This is my contact mail, and please don't hesitate to contact me if you have needs, questions, and other stuff to communicate together. Okay, thank you.
Thank you, Massimiliano, for your interesting lecture. So now it's time for questions. So if there are some questions, please, you can write your questions in the chat, or if you want, you can open your mic and you can, and of course, your video, and you can, provide your question. So. Okay, probably it seems that we have no questions.
I was very, very clear.
Yes, that's the point. Usually. In any case, Massimiliano, because they have to to get the learning test. I mean, I would like if you can stress some points regarding the questions that they are going to I mean, to make and to reply. So just, I mean, to make a short resume and for them in order to have a good chance for a successful test.
Okay, sure. I mean that the questions are not so complex and so difficult, but some of the take-home messages of my speech, of my lesson, and this experience from the field is that we have to take in mind to analyze many contextual factors, so have a wide mind and go to understand very well with the context where people live and to understand a lot of factors. And the second point, we have a lot of chance to use different technology. So sometimes they are specific, sometimes there are wide market technology, but a good idea is to work in a mixed way, okay? Because we have to reason as a system, okay?
Yes, we have some questions for you now. Husama Rashid Qureshi is asking, any specific applications on IoT services in healthcare sector and genetic rare disease?
Yes, sure. I mean, AT centers are in general very focused on this kind of application because, of course, I mean, now also base local, for example, healthcare service have quite a good know-how on basic AT. What one of the main point of the mission of assistive technology on difficult cases, and sometimes genetic and rare disease sometimes have very specific need, and usually in this case we could not go with a wide market, but we have to go for very specific IT solution for very specific functionalities. But the good point is that we have solutions. If and what's very interesting, for example, database for this is the Eastin database. Yeah, I can write in the chat.
Yeah.
And this database is have connected several national databases, and there you can find a lot of information about technologies and the different solutions, and sometimes there are also case studies. So keep this as a very, very important research about assistive technologies. And about privacy, well, privacy is quite complex. Of course, when we design new system, we use a privacy by design approach, so could be easily managed. The very big problem now is when we go on wide market IoT solution, like for example using voice assistant and smart speakers and so on. So well, this is a big problem when we use I mean the accounts for smartphone and so on. So well, good, this is a big challenge. So what we will hope is that also by this point of view it will be make available the possibility to protect more data, but we know that the big companies of ICTs have a lot of interest in this data. So on one hand, we should try to use this solution because they're very cheap. We can go very nice things, but when we have to protect data, we need to switch to, I mean, professional solution. This more or less is that's a very big problem to manage this connection with the big companies of ICT, and we should use that kind of solution. So I'm really sorry because I have to move in another lesson. So, but you have my reference. I mean, I will give to Andrea and all the staff my slides. So please don't hesitate.
Learning assessment agi chal bhai. Teachers ki these are the links for today.
Okay. Yeah.
Good. है ना?
Wonderful. Yeah. Okay. And so
Thank you, Massimiliano. I mean,
thank
for
you
your.
everyone, and of course, don't hesitate to contact me. Okay. Thank you, Andrea.
Thank you.
Lorena.
Thanks, very good.
Thank you. I hope it was interesting. So bye-bye.
Bye.
Bye, Massimiliano. So, Lorena, you can go ahead.
Yes, I posted the link in the chat. If you want, Andrea, you can share even an email that I have sent to you. Excuse me for the delay. And we will see again on Friday.
Yeah, exactly. So you can write these, but I mean, you copy and paste these links. But now, I mean, just in a few minutes, I will send this by emails, okay, to all of you.
Chalo ji.
Okay. So thank you again for participating, and at this point, so we will see each other on Friday for the third day of the summer school. Okay. Thank you for attending. Thank you, guys.
Bye-bye.
Thank you.
सारों का very good कर दिया भाई.
Bye. Thank you. Bye.
मेरा बंद है. तब से क्या है?